Let us solve the system of equation x plus yz equal to 2, y plus zx equal to 2 and z plus xy equal to 2 simultaneously. So we have three different equations. X plus yz equal to 2. Let's write this as equation 1. Y plus zx equal to 2. Let's write this as equation 2. And z plus xy equal to 2. Let's write this as equation 3. We want x, y, z such that those x, y, z will satisfy all the three equations. So what we do is we subtract equation 2 from 1. Subtracting equation 2 from equation 1, we obtain. So first we write equation 1, x plus yz equal to 2. And then equation 2, y plus zx equal to 2. So we are subtracting equation 2 from 1. Now why we subtract equation 2 from 1? Because x minus y, you see that it's somewhat symmetric. X minus y will get x minus y. And not only that, you see that yz minus zx, if you take z common, you will again get x minus y. Let's do it. So we have x minus y common. Sorry, we got x minus y. And we take minus z common. We're again obtaining x minus y equal to 0 as it is. Now we take x minus y common once again. And then we are left out with 1 minus z equal to 0 as it is. Now we see that product of two numbers equal to 0, then one of them has to be 0. So either x minus y equal to 0 or 1 minus z equal to 0. We don't know which one is it. Maybe both of them are 0. So we start by case 1, the easier one. Case 1, 1 minus z equal to 0. Well, that obviously means z equal to 1. Now we look at the equation 1. If I write z equal to 1, I'll get x plus y equal to 2. We look at the equation 2. If I write z equal to 1, I'll get x plus y equal to 2. So from equation 1, x plus y equal to 2. Let's write that z equal to 1 in equation 3. From equation 3, 1 plus xy equal to 2. 1 plus xy equal to 2. Take 1 to the right hand side, xy equal to 1. So we know the value of x plus y. Let's write it as equation 4. We know the value of xy. Let's write this as equation 5. Now we know the formula that x minus y whole thing square equal to x plus y whole thing square minus 4xy. By equation 4, we know x plus y equal to 2, so this is 2 square. And by equation 5, we know xy equal to 1. So this is 4 minus 4 equal to 0. So x minus y whole thing square equal to 0. That means x equal to y. Because x minus y whole thing square equal to 0, that implies that x minus y equal to 0. And obviously when x minus y equal to 0, x must be equal to y. Now let's write x equal to y once again in equation 4. Therefore, by equation 4, 2x equal to 2, so x equal to 1. So we obtain x equal to 1, and then again by equation 4 we'll get y equal to 1. By equation 4, x plus y equal to 2. Yes, x plus y equal to 2, but x equal to 1, so 1 plus y equal to 2, so y equal to 1. So we got x equal, when z equal to 1, x equal to 1 and y equal to 1. So in this case, we got a unique solution. X comma y comma z equal to 1, 1, 1, or simply we can write x equal to y equal to z equal to 1. Now let's look at the other case. When 1 minus z equal to 0, we got z equal to 1. But when x minus y equal to 0, so case 2, the bit difficult case, as compared to the case 1 that we have handled. In case 2, we have x minus y equal to 0, that is y equal to x. Now let's write this value again in equation 1. By equation 1, if I write y equal to x, then I get x plus xz equal to 2. By equation 1, x plus xz equal to 2. By equation 2, again we replace y by x, so we obtain x plus xz equal to 2. Oh, same thing, no change. X plus xz equal to 2. But what about equation 3? Z plus, equation 3 says z plus xy equal to 2, and we have x equal to y. So by equation 3, z plus x square equal to 2. Now we can solve for x and z. So far we have gone up to equation 5. Let's write this as equation 6. And this one is 7. Let's solve for x and z from equation 6 and 7. From 7, z equal to 2 minus x square. We write that value of z in equation 6. By 6, x plus x into 2 minus x square equal to 2. So that's a cubic equation. So we can write it as x plus 2x minus x cube equal to 2. We take everything to the left hand side, or let's take it everything to the right hand side. 0 equal to x cube minus 3x plus 2. So we obtain a cubic equation. You can see it easily that x equal to 1 is a solution of this equation. So we can factorize it. Since x equal to 1 is a solution of equation, let's say 8, is a solution of equation 8, comma, x minus 1 is a factor of x cube minus 3x plus 2. Therefore, we can write equation 8 as x cube minus x square. We get x minus 1 as a factor, but we have to adjust it to make it equal. So we add x square, and then we want x minus 1 as a factor. So minus x minus 2x plus 2 equal to 0. So we take x minus 1 common, left out x square. We take x minus 1 common, we are left out with x. We take x minus 1 common, we are left out with minus 2. Again, we can factorize this one by splitting the middle term. X squared, 2 into minus 1 is minus 2. So plus 2x minus x minus 2 equal to 0. So we factorize it. We take x plus 2 common. We take x plus 2 common. We will be left out with x plus 2 whole thing into x minus 1 equal to 0. So you see that we have 3 different answers, but 2 of them are same. X equal to 1, that we have already shown that when x equal to 1, x or y, z, all the 3 are equal to 1, or x equal to 1, or x equal to minus 2. If x equal to minus 2, by equation, let's look at the equation 1 once again. If x equal to minus 2, you get minus 2 plus yz equal to 2, and y minus 2z equal to 2. If x equal to minus 2, from equation 1 to 3, we get minus 2 plus yz equal to 2, and then y minus 2 plus yz equal to 2, and then y minus 2z equal to 2. So, and then z minus 2y equal to 2. Z minus 2y equal to 2. That's it, x equal to minus 2. So, z minus 2y equal to 2, correct. Y minus 2z equal to 2, correct. It will be easier to solve these two equations. So, let's write this as equation, say 9, and this one is equation 10. Let's multiply equation 9 by, okay, yes, let's write once again, minus 2z plus y equal to 2, and equation 10 is z minus 2y equal to 2. From 9, we can write y equal to 2 plus 2z. From 9, y equal to 2 plus 2z. We substitute it back in equation 10. Z minus 2 into y equal to 2 plus 2z equal to 2. Let's simplify it. Z minus 4z equal to 2. That gives us minus 3z. So we obtain minus 3z equal to 6. That gives us z equal to minus 2. Let's write value of z in equation 10. Minus 2 minus 2y equal to 2. That gives us minus 2y equal to 4. So y equal to minus 2. Therefore, other solution is x equal to y equal to z equal to minus 2. And earlier we obtained x equal to y equal to z equal to 1. These are the only possible solution.